Chapter 1, Lesson 5, Geometry, Video D. This will be the final video in this section. And what I'd like to do is to talk about this definition of midpoint, and then we'll go ahead and do some examples involving both segment addition and midpoint, following our 4 steps: recognizing the relationship within your figure, writing the algebraic expression, and then determining the value of x, or the missing value. Okay? So as we read this, again, whenever we read a definition, postulate, or theorem, we want to go ahead and highlight the important parts and only write those down. We don't need to write down everything. So let's go ahead and read this. A midpoint of a segment is a point that divides the segment into 2 congruent segments. So it divides into 2 congruent segments. Any midpoint, a line, a ray, or other segment through a midpoint is said to bisect the segment. So here we have another word that's in italics, which, by the way, is another thing that when you're reading a textbook you want to look for words that are in italics, because those are important words as well, not just highlighted words. Okay, so if we take that whole paragraph then and we can kind of settle that down into a few key points. A midpoint is anything that divides something else into 2 equal parts, or a point rather that divides a segment into 2 equal segments. Okay, so here's the segment AC. If you look at the entire segment here, B is in the middle, so that means that AB, this segment over here, is congruent to BC. And remember, or notice these tick marks. Each segment has 1 tick mark, which means that these 2 segments are equal in length. That's what those tick marks mean. Okay. Another word we had in here was bisect, and that's anything that goes through that midpoint. So if you have a midpoint there, if you draw a line through here, or a ray through here, or a segment through there, any of those line segments or rays would be what we call bisectors, or they would bisect that big segment into 2 smaller ones. So bisect, you're going to see a lot this year. It means it cuts things into 2 equal parts. Okay, and midpoint means it cuts things into 2 equal parts. Now these are definitions, which means they're going to be used as reasons for writing explanations. For instance, right over here, if we just use the example we have here, again using the first 2 steps that we've been talking about, I look at this, what's the relationship here? Now I actually have 2 relationships here where AB and BC are equal because of this. So what's the reason? How do I know that? That's because that's the definition of a midpoint. Okay, so this is a little bit different than segment addition postulate, in that it's not a postulate, but it's actually understanding the definition of what a midpoint does. What does a midpoint do? It says right here, it cuts something into 2 equal parts. Has AB and BC, or has AC been cut into 2 equal parts? Yes. By what point? B. Well, how do we know that? Well, that's the definition. That's what a midpoint does. Okay, so whenever you use midpoint, that's going to be definition of a midpoint. So let's do a few examples, and again, I'm going to use some examples that have to do segment addition postulate as well. Seeing how we've been talking about midpoint, let's go ahead and do that one first. So it says here C is the midpoint. I have to be told that. There aren't any tick marks here. So because it says C is a midpoint, what does that tell me about this segment AB? It's been cut into 2 equal parts, right? So following my 2 steps, I recognize that my definition, whoops, don't know what that came from. As soon as I see the word midpoint, I know that something's been cut into 2 parts. What's been cut into 2 parts? AB. What are the 2 equal parts? So what I can write is that AC is congruent or equal to CB. How do you know that? Well, that's the definition of a midpoint. So again, this is the geometry course right here. Understanding the definition and then writing an algebraic expression from that. Once I know that, then I can go ahead and substitute these values in. So what is AC? Well, they tell me AC is 2x plus 1. And what is CB? Well, CB, they tell me, is 3x plus 4. So I substitute these in. I now have an algebraic expression with variables which allow me to determine the value of the variable. Again, if you skip this step right here, if you just jump right to here, you're skipping geometry and jumping right into algebra. And again, this is a geometry course, so you must have the algebraic expression and the reason why that algebraic expression is true. If you don't do that, you're skipping geometry. I can't give you, full credit that you understand geometry. You have to be able to give reasons, all right? So once we have this, we go ahead and solve, and we have this x is equal to 5. Now the nice thing about doing this is being able to then check my work. There's no reason to get this wrong. What did we say at the beginning? That AC and CB are equal. So if I'm now knowing the value of 5 is the value of x, if I put 5 back in for x here, and I put 5 back in for x here, I should get the same thing because I started off by saying these are equal. So I can check my answer by putting that back in, and I get 11 for AC, and I get 11 for CB. Therefore, I know these are my correct answers because these are equal. And it did ask me to find AC, CB, and AB. So I found AC and CB. How do I find AB? Well, that's those two added together, which would be 22. Okay, so it's a nice way to be able to check our work.